there is another very interesting phenomena which happens in nature. See, when rain happens, what do you think the height of cloud must be? Clouds must be from the surface of earth. They are approximately 6,000 meters or 6 kilometers from the surface of earth. Okay, if I have to calculate the velocity of raindrop which is falling from this height, how would I calculate it? A simple formula, v square minus u square is equal to 2as. I am finding out final velocity with which raindrop strikes the earth surface or strikes us when we are in a rain. So v square, initial velocity 0, 2 times oscillation, I am taking it 10 for convenience, s 6,000. What will I get? 6 into 2, 12, 1, 2, 3, 4 zeros. This is v square, or v is equal to under root this much value. What will this be? This one, and root 12. It will be definitely more than 3 point something. I'm just taking it 3. Okay, so the velocity is greater than 300 meter per second. So is this the velocity of raindrops which hit our surface or hit us? No, because this velocity is even more than the velocity of bullet fired from a gun. So why does not this thing happen? Because we have actually calculated the right distance thing. So this should be the velocity of raindrops when they strike the surface of earth, and with this velocity they can even penetrate, or they can actually penetrate through our cars. But this thing never happens. Why so? The reason is because we are studying about terminal velocity. This is the reason. Terminal velocity. Now what is terminal velocity? When a body falls from another viscous medium with certain velocity, its velocity increases up to a certain limit, and after that it becomes constant. That maximum velocity, that maximum constant velocity with which it further falls down is called terminal velocity. So what is terminal velocity? It is the maximum velocity, maximum constant velocity with which a body falls through another viscous medium. So consider this raindrop, spherical raindrop falling through this medium, viscous medium. Let it be air. Okay, density of this body be rho, and outside density be sigma. Okay, viscous force here is, viscosity is eta. All right, radius of that raindrop be r. I am just taking an example of raindrop, but otherwise this formula, this terminal velocity is applicable everywhere. Okay, just to make you understand, I'm saying this thing in terms of raindrops. Now when it is falling freely, what are the forces acting on it? Number one, weight, that is true weight of this drop, true weight of this body which is acting downwards. But there are two forces which are acting upwards. One is buoyancy, that is upthrust, the buoyant force which will be acting due to the amount of or the weight of fluid displaced by this body, that is upthrust. Another one is viscous drag force, which we just studied. So viscous drag force which will oppose the motion of this body in the viscous medium. So what will happen? As the velocity of this body will keep on increasing, so will be the increase in the value of viscous drag force, and ultimately there will be a stage when it will all come to a saturation point. That means the net downward force or the true weight of the body will be equal to net upward force, that is sum of upthrust or the buoyant force and the viscous drag force. And when that will happen, then there will be a constant velocity which this body would have achieved, and with that velocity only it will complete its journey or fall down with that constant velocity. Now, to find the value of that velocity, what is true weight of the body? Mg for this body will be equal to upthrust plus upward drag force. What is mg of the body? M is volume into density, that is 4 by 3 pi r cube. Volume into density of the body is rho g. This is mg. Upthrust, this is the weight of the fluid displaced. So weight of the fluid displaced will be again mg, but instead of mg I'll be writing it v rho g, that is volume into density into gravity. So volume would still be the same because the volume of the body will be equal to the volume of this fluid displaced, but this time density will be of that fluid, right? And plus what is viscous drag force? 6 pi eta rv, right? So now we can find out the value of this velocity. How? taking this thing that side, I'll get 4 by 3 pi r cube, this minus this, g upon 6 pi eta r, 6 pi eta and r. So what are the things cancelling out? Pi, 1 radius, 2 is left, g remains, out of 4 becomes 2 and this becomes 3, and what else? Nothing else. So the formula of velocity comes out to be velocity or terminal velocity Vt. This is equal to 2r square, difference in the density of body and the fluid in which it is passing through, times gravity, upon 3 into 3, this 3 into that 3 becomes 9, 9 times viscosity. So it is very clear from this formula that the terminal velocity is directly proportional to radius raised to power 2, that is the radius of the volume of the body or the size of the body. It is also inversely proportional to viscosity of the medium. Lastly, difference in the density. So what if the density of liquid in which it is flowing is greater than the liquid of the body itself? What if that means sigma is greater than rho? This will make this thing negative, velocity negative, that means this body is going to move in upward direction. This is the reason why the bubbles in a soda bottle always rises up. They don't go down, they rise up. The reason is this: the density of fluid in which they are flowing is greater than the density of their own body. So this gives you the value of terminal velocity for a body which is moving in a fluid.